My name is Rajneesh Chandra, and I will be discussing the concept of limit fits and tolerance in manufacturing. Measurement is of utmost importance in manufacturing. Nothing can be measured to exact number, and there will always be limits. If the nominated length of a workpiece is x millimeters, then the nominated tolerance would be plus or minus y millimeters, meaning it would be acceptable for the piece to be x plus y or x minus y millimeters. X plus y millimeters would be the upper tolerance limit, whereas x minus y millimeters would be the acceptable lower tolerance limit. Let's look at this workpiece over here, which is 35 millimeters nominal length, and the tolerance limit over here would be plus or minus 5 millimeters. So in this case, the nominal length is 35 millimeters, the lower tolerance limit is minus 5 millimeters, and the upper tolerance limit would be plus 5 millimeters. Therefore, the acceptable length for this workpiece would be 35 plus or minus 5 millimeters. In today's manufacturing world, various components may be manufactured by various suppliers at different locations and then assembled at a main assembly plant. If parts from different suppliers do not fit together properly, then main assembly would not be successful. It is therefore very important that suppliers are made aware of the customer's manufacturing tool. Limit fits. Limit fits may be used when manufacturing shafts, gears, pulleys, propellers or bearings, or other rotating disc-like metal objects. These discs, or these so-called discs, are usually driven by shafts. There are usually three types of shaft fits, or disc to shaft fits. These are clearance fit, transitional fit, and interference fit. For clearance fits, there is a clear gap between the shaft and the hole. The hole would be in the disc, and the shaft would be able to freely slide in and out of the disc hole. The tolerance here would be that the lower tolerance would be that the minimum hole size would always be larger than the maximum shaft size, and the upper limit would be that the maximum hole size once again would be larger than the minimum shaft size. Interference fit gives a tight or press fit. The shaft and the disc therefore may become fused together to form a permanent fit. In interference fit, the minimum or lower limit of the disc is always larger than the higher limit of the hole in the shaft, which means that the shaft diameter is always larger than the hole diameter of the disc, which means that to get the shaft into the disc or the hole, the shaft would have to be force fitted or press fitted into the disc. Transition fit lays in between the interference and the clearance fit. Various manufacturing or working processes can only be done within certain tolerances. Engineers, production managers, tradesmen, designers therefore should be aware of the processes before choosing them. Some of the processes and their tolerances are flame cutting, 0.5 to 2 millimeters, laser cutting, 2 to 5% of the thickness of the workpiece, depending on the thickness of the workpiece, drilling, 0.3 to 0.05 millimeters, sand casting, 12.5 to 25 new meters, hot rolling, 12.5 to 25 new meters, forging, 12.5 to 3.2 new meters, cold rolling and cold drawing, 0.8 to 3.2 new meters.